All right. Well, welcome everyone to our third part in our webinar series on the AWS Well-Architected Framework. Looking forward to going through the security pillar today, which turns out to be one of the most popular and in-depth pillars of the Well-Architected Framework. So first, let's do some quick introductions. My name is Jonathan LaCour. I'm the Chief Technology Officer at Reliam. I've been kind of using cloud and cloud infrastructure since the very early days of AWS. I'm a technologist and a cloud strategist, and a big fan of Well-Architected as well. So a little quick bit about Reliam and our business. Interestingly, since our last webinar, over the last kind of month and a half, 2 months, we've merged with two other businesses, Stratalux and G2 Tech Group. The three of us together have created a consulting and managed services group that has a huge amount of expertise with AWS. Now we're bi-coastal with presence in both Boston and Los Angeles. And we have the DevOps competency, managed service provider, healthcare and life sciences as well. So that's a little bit about Reliam. So first, we want to make sure that everyone enjoys being here, is a little bit engaged, and get a little information about our audience. We're going to do a couple of quick polls. These are all completely anonymous, so your answers cannot be tracked back to you, so feel free to be completely honest. And the first question is really how your company is currently using AWS. I want to get a little bit of a gauge on that to see, what the audience looks like here. And I get a little sneak peek as answers roll in. So I'm seeing some answers kind of come in now. Great, give it another minute here or 30 seconds. All right, let's go ahead and close the poll. All right, so it looks like about half of you are currently using AWS for production, which is your perfect audience members for this. And for those of you who are testing or taking a hybrid approach, you're all going to learn lots of great information about how to take full advantage of AWS today. So let's go ahead now and talk a little bit about our agenda for today's webinar. We're going to start off by doing a kind of quick sprint through an introduction to what Well-Architected Framework actually is, and a little bit about how partners like Reliam really engage with our customers through Well-Architected. Then we'll talk about the design principles for security and the AWS shared responsibility model, which are kind of a key factor for security in AWS. And then we'll talk about the in-depth focus areas for security. There are 5 of them, and each of those has a whole collection of best practices and information. So let's get started. So first, as I mentioned, let's talk about the Well-Architected Framework itself. So in 2015, at AWS's annual reInvent conference, Werner Vogels, the CTO of AWS, he actually announced the Well-Architected Framework. And it was a series of 5 white papers across 5 separate pillars of best practices and guidance for being well-architected in AWS. And altogether, the framework makes sure that your applications are taking full advantage of all of the best practices available for AWS. And AWS has continued to evolve the Well-Architected Framework, and now I believe it's actually the most complete and thorough collection of best practices and advice that you can really get out there for any organization who is wanting to go through the cloud transformation. So let's talk about the benefits of Well-Architected. There's actually quite a few of them. First and foremost, the principles and the best practices there help you move more quickly. And in my experience, this is the biggest demand on any team, any technical team or product team within an organization, is go faster. And it also helps surface risk and helps you address those risks before your apps are put into production. This is another critical factor. And as a CTO, I frequently have to make big, financially meaningful decisions, as I'm sure many of you do as well. And the Well-Architected Framework helps focus your organization on that rapid decision making that's necessary to do that job well. Another common problem we all face is benchmarking ourselves against other architectures and procedures and systems against best practices. And Well-Architected is an awesome way to do that because it has a whole series of best practices that AWS has learned based upon their experience with their many thousands of customers. So Reliam is capable of doing well-architected reviews. We are actually a launch partner with AWS for the well-architected program. And what that means is we can send our solution architects on site to your organization and go in depth across all 5 pillars and identify areas where there might be some work necessary to become fully well architected. And these are some of the insights that we've learned after doing dozens of well-architected reviews. And very timely for today's webinar, 92% of the reviews that we have performed have surfaced critical security issues. And so, you know, even if you are confident in what you've built, I assure you there's always new and interesting things available in well-architected that you may have missed. So it's a very valuable framework to apply. Another key thing about that well-architected program through AWS is they work with partners like us to essentially give people the ability to get a lot of free insights out of AWS and Reliam. So what we generally do is we're able to do those well-architected reviews for free, and AWS will actually give a $5,000 credit to the customer on their AWS bill, and then use that to offset any remediation that we can provide, which usually comes in the form of professional services hours. So this is an awesome way to engage and get connected really quickly with the well-architected review program. So let's dive in now. That's enough about background. Let's talk about the shared responsibility model. And this is kind of a foundational element to AWS's view on security in the cloud. So what we see here is a chart or graph showing kind of what the shared responsibility model looks like in practice. And on the bottom in orange is what AWS views as their responsibility. And their responsibility is the security of the cloud itself. And that means things like the hardware, the low-level virtualization software, storage, database, network that kind of operates the cloud itself. And where you as the customer are responsible is in that blue area up top. And that includes your customer data, any applications that you built, software, the operating system on any virtual machines that you're running, network and firewall configuration. So there's still quite a bit of responsibility for you as the security in the cloud. So AWS is responsible for the security of the cloud, and you as the customer are responsible for security in the cloud. And Reliam actually includes the AWS shared responsibility model in all of our statements of work and kind of engagements with our customers to make sure that we're all on the same page about what the responsibilities are. Reliam as a managed service provider, frequently we plug ourselves into that kind of blue area at the top, and on behalf of our customers, we help them manage things like their operating systems, their network and firewall configurations, and so on. So that's a little bit about the shared responsibility model. So now let's dive into the well-architected security pillar itself. And the security pillar has 6 design principles. Each of the well-architected pillars has a set of design principles as well. And these are, generally speaking, high-level principles for how you should architect and build your applications with that pillar in mind. And let's go through each one here in depth. So the first one is to implement a strong identity foundation. And that makes sense that this is the first design principle because it is really foundational. In many ways, access control based upon identity is the fundamental foundation upon which you build your entire workload, right, for security. And that said, controlling access to your resources in AWS can be pretty challenging. And that's because AWS provides such a deep, granular, and powerful access control capability through its IAM, or Identity and Access Management Service. And in my view, the easiest way to kind of summarize this design principle and the approach you should take is the principle of least privilege. And that's a common principle that's applied throughout computing. And Wikipedia defines it as a principle which requires that in a particular abstraction layer of a computing environment, every module must be able to access only the information and resources that are necessary for its legitimate purpose. So in short, this principle is all about using that IAM service to ensure that access to all of your resources in your cloud environment are denied by default. And access is granted only to users and systems that require that access to do their job. And not only are they granted that access only if it's required, but only for a time duration and scope that makes sense for what is trying to be accomplished. So you really want to grant the least privilege necessary for the least amount of time. So that's implementing a strong identity foundation. So let's ask another quick poll question here. And first of all, hopefully some of you have heard of the principle of least privilege, but now that you know what it is, I'd like to hear a little bit about if the audience is applying it in your workloads right now. So up will pop a new quiz. And again, totally anonymous. You don't have to be ashamed if the answer is no. I expect that many of you are. Let's see. Great. Thank you so much for your participation. We're getting a pretty good number of you answering very quickly. It's great. Okay, 1 or 2 more seconds here. All right, let's see what the results are. All right, a nice clean 74% yes. So good for you. And those of you who aren't, I'm guessing when we engage with customers and they're not fully applying the principle of least privilege, it's generally speaking not a huge pervasive issue. It's little pockets of oversight, right, that can be addressed pretty easily. And so I think that that's an encouraging thing for everyone to be aware of. You're not alone in that. Okay, the next design principle for the security pillar is to enable traceability. And this principle is mostly about preparation, right? Your operations team is going to have to put up with a security incident at some point. They're going to have to deal with it. And no matter how much you work to prevent it, your critical factor is your response, right? In the event you do experience a security incident, you want to enable the team to keep a cool head, have situational awareness, and have the information that they need right at their fingertips. We're going to dive deep into this later as we get into the focus areas, but the idea is really that you should have integrated logs, metrics, and all of the information put together in a system that helps your team respond quickly, and your systems also to automatically remediate. So it shouldn't just be people responding to an incident. It should be systems who are that are capable of automatically helping to respond as well. And the only way to really do that is to enable that traceability. So we'll have some more best practices about that in a moment, but that's the second. So the third design principle is to apply security at all layers. So this is the famous Shrek principle, for those of you who have seen that movie, right? Security is like an onion, right? There's lots of layers. It's a very common mistake for organizations to take an approach to security that focuses on the edge, the border, the outer layer of the application. Things like making sure your kind of web front ends are secured, but then kind of ignoring and saying, oh, everything that's behind that is on a local network, so it's all safe. And I think that's a fallacy. That's not a good way to think about it. You really want to secure every layer of your application and your system. Why is that? Well, if someone breaches the outer layer of your workload, right, even if you secured it really well, there's a possibility someone could breach, and you don't have additional layers of protection beyond that outer boundary, they have the keys to the kingdom. They can get access to all of your customer data, everything that have complete control, and that's exactly what you want to avoid. So the more layers of protection you put in, you limit that blast radius, right, in the event of a breach, and you also slow down the attacker, right? There's more things for them to jump through, more hoops for them to jump through to actually exploit you in that kind of breach. So applying security at all layers is a key principle for the security pillar. So next up is one of the most near and dear to my heart, which is automation, automating security best practices. I have a personal passion for automation, and that's because of my engineering background. And while the first part of making security a priority really is people focused, getting engineers, product owners, executives to really make security a priority, the evidence, though, of that cultural shift and cultural change taking root is automation. Many security best practices can actually be applied or tested in software using configuration management tools, infrastructure as code templates, and a bunch of services that AWS provided to basically codify your best practices and ensure that you stay up to date with them. Reliam, we are a managed service provider, so we have hundreds of customers that we manage their workloads, and we use Chef for our configuration management platform, and Terraform for infrastructure as code, along with CloudFormation. And we maintain a carefully tested library of recipes and templates that consistently apply those best practices across all of our workloads. And not only does that ensure that we remain consistent, it also helps us to roll out and evolve best practices, right? So if we learn of a new technique or a new type of threat that we need to be scanning for and mitigating, we can apply that to our common library and then evolve very quickly, right? That out to our entire fleet of infrastructure that we manage for our customers. So another quick poll, and that one is about automation. Does your organization apply some of those same ideas? Are you automating security best practices? And while you're answering, I'll point out to everyone here that we actually have a privilege of having one of our senior engineers, Brian Young, on the webinar with us today. He is watching the chat and the questions section of the webinar. You can actually go in there and you can put in questions. Brian, over the course of the webinar, will do his best to provide some answers to those questions and his own insights based upon his experience. Answers are still rolling in. And then at the end, we'll review some of the most common questions and leave some more time for more questions. So just be aware of that. Okay, let's stop the poll. Wow, this is a fairly even split, but it looks like this is actually not a common practice for most people here today. And that doesn't surprise me too much, because a lot of times our automation really focuses on other aspects, right? Things like our CI/CD pipeline. We'll talk a little bit more about best practices about how to apply security into your automation as we go ahead. So that's encouraging. It sounds like we'll have some insights for everyone. Okay, next up, the next principle is to protect data in transit and at rest. We're going to go into depth on both of these, but let's just start providing some context. So the notion here is that in any given application, the data that application manages isn't really uniform, right? You'll have data with varying levels of sensitivity and security kind of threats. You'll also have data that mostly sits in storage, and other data that is constantly being accessed or even transmitted around frequently between microservices or components of your system. And AWS recommends classifying and segmenting your data and having a sort of well-maintained mapping of where data lives, how it's being used and accessed, and how sensitive it is. We'll, again, go through more detail on this in a bit. But they also recommend using things like encryption and tokenization, and they recommend that you try to eliminate direct human access to data. So this is a big aspect of what we do at Reliam. We really try to ensure that, for the most part, data can only be accessed through well-maintained systems, right? With clear ACLs, a good definition of the principles, and the security policies, right? Direct human access is not just handed out in an unfettered way. So that's protecting data in transit and at rest. So the next is about practice, right? Prepare for security events. This is the last design principle, and we've pointed this out before. You will at some point encounter a security event, and it's really important that your teams are prepared. So it's not just having all of the data at your fingertips, right? Enabling that traceability. It's also practice, right? Having documented procedures and then practicing them on a regular basis, going through simulations and game days and refining those procedures based upon what you learn. Over time, you're kind of developing that muscle of being prepared for those security events. So in the event that you do have a breach, you're ready. You've got all the data at your fingertips. You have a well-practiced and defined policy and procedure, and you can execute against it to remediate very quickly. Okay, so now let's dive into the 5 focus areas of the security pillar. And these are the more in-depth collections of best practices. So let's start with identity and access management. So this was a design principle and it's a focus area. As we said, identity and access management are foundational when it comes to building secure systems. AWS actually outlines a process in their well-architected white paper talking about how to apply IAM kind of through your systems. And it starts from the top down. So first up, you want to define your principles. A principle is a user, group, or service or a role that takes an action in your account, really anything that can take an action or access a resource. The next step is to craft policies that outline precisely what each principal is capable of doing and why, right? And for how long they should be granted that access. And that's really the first part of a least principal methodology, or least privilege methodology. The AWS IAM service gives you deep, fine-grained controls to implement that. And now that we define our principles, we can talk about the best practices for identity and access management along two main topics. First is protecting AWS credentials, and the second is fine-grained authorization. So let's start here with protecting AWS credentials. So this is a huge section of the white paper with many, many recommendations, and we'll go through some of the highlights here. So the first is that credential management should be intentional, right? Not a haphazard kind of afterthought. And that means that you should build out a policy for credential management and you should enforce it carefully. The second best practice here is to handle the root user with care. So when you sign up for AWS, every account is given a single initial identity, and that's what's created to let you do set up everything else in your account. But that root user has access to literally everything, and so you have to handle it with extreme care. AWS generally recommends that the root user isn't used for everyday tasks at all, and really you should protect it with multi-factor authentication, and you should only use it for the purpose of setting up the other principles, right? Creating your initial set of IAM users and roles and groups that will collectively be used to handle all of the identity management from that point forward. So it's a use it once to get everything set up, protect it carefully with a strong password and with multi-factor authentication, and then use your other kind of identities after that point. And another best practice is to leverage existing identity providers. So many organizations, especially large enterprises, have an existing source of truth already, a record of identity in their organization. And you want to avoid creating a split brain, right, where identities have to be manually managed across both. And AWS provides full integration into IAM with SAML, right, which is an industry standard that you can use to integrate fully your existing kind of record of identity with IAM in AWS. And that'll help you consistently apply trust to your identities and limit the need to create those duplicate records. Next up is to implement and enforce strong authentication. And that means a very strong password policy with things like minimum password length, complexity for passwords, rotation, and mandatory multi-factor authentication, especially for users that require access to the AWS console. The AWS console is a very powerful place where you can really shoot yourself in the foot and make a lot of mistakes. So making sure that that access control is strong is critical. If you have users that require or systems that require API access, federation tends to be a little bit impractical. And in those cases, AWS actually recommends that you issue access key IDs and secret access keys. And then you can use those and assign them and associate them with IAM roles. But when issuing those, you have to take care to store them carefully, right? Only in secure locations and never in source control repositories. So a quick horror story for you. GitHub is a popular place for people to put their projects, and a common practice these days by bad actors is actually to scan GitHub and other public kind of repositories looking for people who have made the mistake of checking in their access key IDs and secret access keys into source control. And very frequently, someone will have their account taken over, and those keys will be used to do all sorts of terrible things, like spinning up, massive numbers of very large, very expensive VMs to do Bitcoin mining and other bad things. So secure those credentials. If you are going to use access key IDs and secret access keys, keep them secret, keep them safe, to quote my one of my favorite people, Mr. Gandalf. So even when dealing with service-to-service authentication, you have to consider security as well. So AWS provides the secure token service, STS, and you can use that to request temporary privilege-limited credentials, and those can expire very quickly or kind of over a time frame that you're more comfortable with. And in addition, you can leverage IAM instance profiles for EC2 instances if an IAM role isn't practical. So those are some of the best practices around identity and access management for protecting your credentials. Next up, let's talk about fine-grained authorization. So we know our principles, we've created and protected our credentials, and now it's time to implement our least privilege methodology using IAM. So I like having a well-maintained set of documentation to outline all of those roles and why they exist and what they're granted to. And you can actually use automation to generate a lot of that documentation programmatically, so you're always sure that it's up to date. And another useful tip is to use AWS organizations and service control policies. That allows you to have multiple AWS accounts and to manage them in a central way, and to share some of your security definitions across those accounts. And one thing I'll point here is, again, when you're defining your policies, those policies must be clearly defined based upon purpose, and the privileges that are granted should be minimal and necessary. So that's fine-grained authorization. So another quick poll here. Again, it's anonymous. So have you locked down the root user on your AWS account? I'm guessing that most of you have. This is actually something that in the AWS console itself, they have a warning. So if you haven't enabled multi-factor authentication, Trusted Advisor will actually alert you, hey, time to lock it down, right? Okay, I'm getting some good responses. Don't be shy. All right, thank you, perfect. Got a good percentage of you voted already. All right, let's take a look at the results here. Okay, 80% of you have locked down your root user, so that's great news. And I would say for the 20% of you that haven't, it sounds intimidating, but it really isn't. It's very easy to go in, enable multi-factor authentication, and to start creating some other identities to use that are, lower in privilege, have less that they can do, limits your kind of surface area of attack there significantly, and it's not that hard to implement. So really good best practice to follow. All right. The next focus area is detective controls. So detective controls have always been important, and this is in the age of cloud, it's actually a lot more critical, I think. Using detective controls, you can sometimes avoid security threats and potential incidents completely. And you can also apply them to enhance governance and compliance, and you can really aid in forensics in the event of an incident. AWS addresses detective controls in the white paper across two main sections. The first is capturing and analyzing logs, and the second is integrating auditing controls with notification and workflow. So let's go through each of those. First up is capturing and analyzing logs. So this is a huge and important factor. This is goes back to that enabling traceability that we talked about earlier, that design principle. As I mentioned, Reliam has been providing managed infrastructure services for customers, and we've actually been doing it for over 17 years, long before the dawn of cloud. And aggregating and analyzing logs has always been a part of our business, right? It's a critical part of understanding what's going on with our customers' infrastructure and enabling us to manage it very well. But the approach has really evolved significantly since we moved out of the data center and into the cloud. There are so many more sources of data to consider, capture, and aggregate, and that means that the volume of data that you have to worry about is enormous. And that means that the traditional approach to log aggregation really isn't viable for us, and I'm betting that for most of you that's also true. Instead of standing up a complex, difficult to manage and scale log aggregation backend, we can now rely on some of the native services in AWS to handle the hard work for us. So that includes services like Amazon Elasticsearch, EMR, the Amazon CloudWatch Logs, and Amazon S3. And Amazon S3 actually is a really interesting use case because you can send so much structured data to S3, and now AWS has introduced all of these great services that integrate directly with your storage layer to provide compute and analysis on top of it, including Amazon Athena, which is one of my all-time favorite services. Athena enables you to actually query against structured data stored in S3 using standard ANSI SQL. So that's a huge benefit. And all of this put together means you don't have to worry about scaling these things. You just have to worry about getting the data and pointing it in the right direction. AWS recommends using AWS CloudWatch Logs with CloudTrail, and other service-specific logging to centralize your data. And once you have that global store of logs, you can perform queries against those logs in an integrated fashion. So you'll see all of the data all together at once. And you can send in application and non-service logs too, using things like agents and syslog and native operating system logs and more. The big challenge there is making sure that your infrastructure is configured to properly send that log data to the right place. At Reliam, we use Chef and other infrastructure as code and configuration management tools to ensure that no matter what we spin up or what we're managing, agents are installed, properly configured, and everything is properly log aggregated, right? So that's capturing and analyzing logs. And again, AWS provides a multitude of services to help you here, so there's really not an excuse for not having centralized logging. So the next part of detective controls to talk about is actually integrating those auditing controls with your notification and workflow. So I've mentioned a couple times already, our experience as a managed service provider with hundreds of workloads to manage, it's really driven home the need for automation and process. We have a huge volume of information to sift through, and so if we're trying to discover anomalies, using manual processing is not practical. And the AWS best practice here is to provide deep integration for security events and findings into your notification and workflow systems. So at Reliam, we have a ticketing system, as I'm sure many of you do as well. We also leverage a collaboration platform and do a lot of chat ops, meaning we can track issues live as they're evolving. And once an issue is detected or we're notified of an issue, it can be automatically or manually escalated, and we can prioritize it and handle it directly from the collaboration platform, doing things like assigning a ticket, closing it, or escalating it right from our chat platform. We also follow the AWS best practice of detecting changes to infrastructure. You really, in the era of AWS, everything can be done with an API. It makes it really easy to spin up new servers, to create new VPCs, alter security groups, and those changes could signify a risk or a problem. So it's especially important to track those changes. We actually watch for changes that are unauthorized or are out of the ordinary, and we integrate those directly into our notification platform, into our workflows to potentially roll back unauthorized changes. And we can route a lot of those notifications to something like AWS Lambda functions to implement automated remediation and notification. So that is integrating auditing controls. So next up, let's talk about infrastructure protection. So infrastructure protection is really about control methodologies around best practices and compliance. And AWS breaks this section down into 3 categories of approach. The first is protecting network and host level boundaries. The next layer down from that is system security configuration and maintenance. And finally, service level protection and enforcement. Interestingly enough, this is exactly what we do for our customers. When we're providing managed services, we try to handle as much of this as possible on behalf of our customers using these AWS best practices. So let's talk about protecting network and host level boundaries. So this is building upon our earlier design principle of security at all layers, right? Providing isolation via your network is one of the most critical layers to security. And that includes not just your network topology, but also the core network design and the management of your network. There's lots of security kind of considerations when designing your network, but a fundamental best practice is this. Design your network in such a way that only the desired network paths and routing are allowed at all, right? And this is applying that same principle of least privilege to your network design. So when setting out to design your network in this way, AWS says that you should start from the outside and move in. So first, consider the publicly accessible parts of your system, load balancers, API gateway, and then think about where you need connectivity between AWS and outside networks or data centers. So if you have a hybrid approach, or you have multiple VPCs, for example, and then you should set up the VPC, including subnets, routing tables, gateways, and your network ACLs, and security groups to support all of those requirements, right? only the desired network paths and routing are allowed. Once you drive down to the host level, you also need to design security groups using the same principles. Instead of having a single security group per instance, which can be difficult to manage and can lead to confusion and difficult management, define a whole set of common security groups with relationships between each other. One of the examples that AWS actually provides in the white paper, I think it's a great example, is to create a database tier security group and an application tier security group, and to use that definition to say the only secure traffic that can happen there, it's limited to instances within the application tier. So nothing else can access the database tier. So as we discussed last month as well, during the reliability pillar, you should use non-overlapping IP addresses when you're defining VPCs. This is to avoid conflict and confusion with other VPCs that you have defined or with your data centers. And you should ensure that you apply both inbound and outbound rules to your network ACLs. A lot of times people miss that and think only about one of those directions. So networks are bidirectional. You have to think about both ways. All right. Next up is system security configuration and maintenance. And what we're really talking about here is servers, right? As much as Lambda is really taking off and serverless is becoming a thing, all of us probably still have servers that we need to manage. They can be a real pain. Keeping your fleet secure is obviously a huge part of protecting your infrastructure. And that means that you have to manage OS level firewalls, scanners for things like CVEs and vulnerabilities and viruses and malware, and a lot more. Again, Reliam manages servers on behalf of hundreds of customers, and thus we take a strict automation approach here. And Amazon has a service called EC2 Systems Manager. It's actually architected in such a way that you can use it with AWS or with another cloud provider or on-prem. We use it heavily at Reliam. You can use it to do things like apply patches across your entire fleet, which is exactly how we use it. You can also use it to do commands en masse across your fleet. And you can use configuration management systems as well to help you here. That'll help you maintain consistent configurations. We use Chef, as I mentioned before. And again, this gets back to the point of limiting operator access, right? Whenever possible, push management tasks through your tools, things like Chef and Systems Manager, to make sure that you've got the proper protections and controls in there. So that's a system security, configuration, and maintenance. Okay, next up is service level protection enforcement. So AWS provides dozens of services with hundreds of features, and every year they announce more. So to limit your surface area of attack, you should really implement as many of those service level protections as well for both your users and your automated systems. And mostly we use IAM for this purpose, creating policies carefully and regularly auditing those policies for accuracy. But it's also important to remember that some services have additional controls that operate at the resource level. Classic example there is an S3 bucket policy, right? So it's not just IAM that you need to consider. You also need to consider service-specific controls. So make sure you consider all of those when you're rolling out your service level protections. Now we get to one of the hearts of the matter here, right? Data. This is a sticky topic lately. I don't know if any of you have been struggling with GDPR or have been reading the news and seeing all of the many data leaks that have happened over the past year, 2 years. This has really driven this issue to front and center. AWS gives us a 5-stage approach that they outline in the white paper that applies to protecting data. And that starts with data classification. And then it builds on top of that classification to protect sensitive data. So let's talk about data classification. So this is the kind of foundational phase. This is all about, and we discussed this briefly earlier, classifying and categorizing your data by levels of sensitivity, by the type of data, where it's stored, and the requirements for access to that data. Once you understand all of that, you actually have to maintain it. It's not a one-time event. You need to continuously update your classification because your application and your workload will evolve. So you should also use resource tags, IAM policies, and other AWS services to implement the policies around that data for classification. In one of my applications, for example, I heavily use resource tagging to categorize systems that have access to things that are sensitive, right? And this really helps me understand where I need to focus in the event of a security event. So that's data classification. Next up is encryption and tokenization. So we often talk about these things together, but obviously they're very different things. They're used for different kind of use cases. So let's talk about each. So first is encryption. Obviously, encryption is all about creating a representation of content that is unreadable without a key, a secret key. And the biggest challenge when using encryption is actually the key management, right? And securing those keys. AWS has kind of attacked this problem head on using the key management service, KMS. It's a durable, secure kind of enclave for keys, and gives you all sorts of redundancy, key level policies, and more. They also created AWS Cloud HSM, which provides you with programmatic access to dedicated hardware security modules. A lot of you out there have, compliance obligations that require you to use hardware security modules, and so you can rest assured you can do that within AWS. So that's encryption. Tokenization, on the other hand, it's about replacing sensitive data with a different representation, a token, and it doesn't contain the sensitive data. It just refers to it. This is particularly useful in cases where you have things like credit card processing, right? Where you have heavy compliance obligations. So PCI compliance is much easier to achieve when your systems are passing around a token which represents a credit card versus actually passing the credit card number around. It's also good for other places where you have things like personal identifiable information, PII, like social security numbers. So that's a pretty key factor as well. So that's encryption and tokenization. So earlier we mentioned protecting data in transit and at rest as a design principle. AWS unpacks that a bit in this focus area, starting with data at rest. It's interesting because AWS provides so many different ways for you to persist data, right? You've got block storage in EBS, you've got object storage in S3, you've got file storage with EFS, databases, archives, Glacier, and the best way to protect data at rest is actually through encryption, right? Conveniently enough, AWS has integrated encryption into all of its storage services, making it a lot more straightforward. And it's integrated with KMS directly. So you can use that same platform to kind of manage the keys across all of those different locations where you're storing data. So if you aren't comfortable using the built-in, kind of encryption mechanisms in AWS, you can self-encrypt and then store that data, right? That is a common practice. AWS calls it out in the white paper. They don't necessarily look down upon it. They want to give you all the flexibility and freedom you need to kind of achieve your goals there. So that's protecting data at rest through encryption. Next up is protecting data in transit. So if you have a cloud native architecture in your application, you're going to have a lot of different services, and those services are going to be flinging data around constantly, right? And some of that data could be tokenized, a lot of it could be encrypted, right? But it's critical for you to protect the data as it's in transit, right? And that means that you need to ensure that you use something like HTTPS with TLS, right? Transport layer security, to secure the data as it's flowing through your application. All AWS services have the ability to encrypt information in transit, okay? And they're all well integrated with the AWS Certificate Manager to help you actually create and manage the certificates necessary to perform that encryption. In addition, you can use the API Gateway service. This actually is breaking news. They announced a feature the last couple weeks for creating private APIs. And that means that you can use the API Gateway to create APIs that are only accessible by specific VPCs. So you can lock it down to kind of your local environment. And when you have systems that have to communicate across VPCs or through external networks, you can also use VPN connectivity. AWS has a variety of ways for you to set up that VPN connectivity, including lots of appliances that are available in the marketplace. So that makes life a lot easier. So that's securing data in transit. The last area of data protection is data backup, replication, and recovery. So data contained within your backups and replicas needs to be protected just as well as the primary data. If you're securing your primary data and encrypting it and making sure at rest and in transit everything is secured, and then suddenly someone breaches in and downloads an unencrypted backup, you know, all of that effort was for nothing, right? So encrypting your primary storage and then failing to encrypt your backups, that's a non-starter, right? So you can use services like Amazon S3 and Glacier. They boast many nines of durability for objects, so you can trust them. They're well integrated with the rest of the services that AWS provides. And Glacier, for example, provides a very low cost target for backups. Reliam actually uses Lambda functions and resource tagging to automate backups for our customers. And we encrypt them and store them securely in S3 and Glacier. And we lifecycle them through to make sure that, you know, we're providing a cost-effective solution for our customers. In addition to all of that, you should consider things like Amazon RDS, right? You should perform snapshots and backups of your databases to S3, all built right into RDS, and EBS volumes as well. You can snapshot them and you can copy them across regions. Amazon S3, EBS, and Glacier all support encryption. For additional security, another thing that you should consider is providing a separate account where you store your backups, right? You can really lock them down in that way. You know, through a lot of the control mechanisms we discussed earlier, it makes that a lot easier to manage. But that's another kind of best practice that AWS suggests you look into. Okay, last area to talk about is incident response, right? So this is preparation prevents perspiration. That's my little easy way for you to remember this. And this is all about being ready in the case of a response or in a security event. And you should have a detailed response and mitigation plan for security incidents, but you can't just have it, right? If your team isn't practiced, you're going to have a very slow response. So I encourage, and AWS encourages, a regular kind of game day simulation, right? Go through the process of putting your procedure to the test. Not only does it give you practice, it validates that your procedures are actually good, right? You may find that a procedure or policy that looks good on paper doesn't actually work well in practice. AWS also recommends using resource tagging in kind of an interesting and unique way. Organizing your teams during incident response. So you could tag a resource and say this particular resource contains highly sensitive data using those data classifications we defined earlier. And then you can also say this team is responsible for this resource in the event of a security event, right? Another best practice is to use all of the APIs that AWS gives you to automate VM isolation and removal. So if you have an incident arise and a particular resource or VM is affected, you could automatically isolate those instances. You could add a security group or alter the security groups to lock it down, right? Then snapshot the EBS volume and move it to a separate location so that you can do some forensic kind of analysis on it. You can automatically remove them from load balancing groups and, you know, auto scaling groups as well. So finally, you should consider the implementation of a clean room approach. And this is essentially saying that before you have a root cause identified for an issue, it's difficult to conduct an investigation because the environment is inherently an untrusted environment. You don't know what's wrong yet, right? So you can use your CloudFormation templates or your Terraform templates to spin up a new environment, a trusted environment, a clean room. And you can use that to perform kind of deeper investigation, kind of look and do forensic analysis there, copying data over from EBS snapshots and so on. So that's another great approach that I've actually deployed in the past myself. Okay, so last question. We've gone through quite a bit of information, and I appreciate you all sitting through that. It's very dense. A little bit curious if you think your organization would actually benefit from going through a well-architected review based upon what you've heard today. So let's see what everyone has to say. Seeing some encouraging results here. Let it keep going here. So while you're answering, I'll mention again, we've done dozens of these. We've actually engaged directly with AWS to train a trainer on our own staff. So we have actually Brian Young, who's been answering questions throughout today's webinar. He is trained to actually train other people to deliver well-architected reviews. So we're constantly adding kind of new team members who can really dive deep with our customers and look at well-architected reviews. So let's go ahead and get an answer here. All right. 70% of you believe that you would benefit from well-architected review. So that's awesome. I think every organization can benefit. And as I mentioned earlier, we have this accelerated well-architected review package that there's a one sheet actually attached to this webinar. If you go to handouts, you can see it there. Take a look. Definitely don't want to put on a sales pitch here at all. We just want to help. But take a look at that, right? It's essentially a free way for you to get an in-depth well-architected review from our kind of staff of trained and certified engineers, and to get that report, right? It doesn't cost you anything, and you get 20 hours of effort out of our smart team to help you remediate anything we find. All right, so that takes us to questions. So quick summary, obviously we talked about the best practices that are involved in the well-architected framework, talked about how we can help you. We talked about the security pillar itself, including the design principles and focus areas. And now we're going to have some questions. So if you have questions, feel free to enter them in the questions area. I'm seeing some questions in there. All right, let's see. Fernando has been particularly active. Thank you, Fernando. He wanted to know, this is a good question, are there previous well-architected framework webcasts available somewhere? And the answer is yes. There's a whole series of links we'll provide after the webinar. You can go in and watch the first two, and then we'll have 2 more after this one. So it's a total of 5, 1 for each pillar. Paul Ling asked if we would have handouts available from those other webinar series as well, and yes, we will. In addition, I believe we posted a lot of this stuff on YouTube and a bunch of other locations as well. We'll make sure that everyone who registered for the webinar gets links to all of that material after the webinar. Fernando had another question. Thank you for being active, Fernando. And please, everyone else, feel free to just type in some questions. Love to answer your questions. What best practices are there for protecting personal data and logs, particularly things like PII data and database query logs? And do we need to take special actions due to GDPR? So I'm going to hold off on that last part of the question because I think that's a very specific kind of question. The first part is about protecting personal data and logs. Yes, there are best practices available for that. I think it's slightly an in-depth kind of thing to talk about in this particular context, right? But there are design decisions and considerations that you can take into account. Brian gave a little answer there that might be useful. I, in the past, have used some of the configurations that are available in the logag systems to go through and say, automatically scrub out things like credit cards, right? And any sort of identifiable information, building patterns and expressions that essentially prevent that data from leaking into your logs. So that's one piece of advice there. I think Brian gave a couple other good answers too. For log analysis, if we analyze logs which contain personal data, even though we're not profiling, should we ask for explicit consent from our users, or can well-architected security be considered a legitimate interest use case for processing personal data? So this is a GDPR specific question, and I will, I hate to do this to you, but I'm gonna punt on this one and say, I am not a lawyer. GDPR is a very specific regulation, and there's lots of very specific interpretations of that law. When I was going through the process of working on our GDPR compliance at Reliam, I worked very closely with counsel to identify very specific cases in which we needed to do some things differently, right? So I'm gonna decline to answer that because I'm not a lawyer, right? I would say consult an expert on GDPR. Okay, so Ryan has a great question, Ryan Ang. You talk about how much to secure applications and systems data, but what if the attacker gains access to your configuration management scripts and modifies them to back up to a server he controls? Besides encrypting the configuration management scripts, what are other ways that you can recommend to protect them? That is an awesome question, right? So again, we talked about the principle of applying security to all layers. This is all about protecting access to your configuration management scripts. I don't think that you necessarily need to encrypt them, or at least you may want to encrypt them at rest, right? But I think having a best practice of auditing those configuration management scripts on a regular basis is a really good idea. That's something that Reliam does. All of our changes to configuration management go through CI/CD pipelines and through code review, because at the end of the day, configuration management and infrastructure as code are everything as code, right? That's kind of one of the benefits of having these things be code, is that they are artifacts that can be reviewed and put through multiple layers of trust and test, right? Okay. Next up, so Roger Walcott asked, do you use Athena to query system logs, and what does the syntax look like? So I've used Athena for a lot of different things. At a high level, what Athena allows you to do is take data that is in S3, right? You can then use the AWS Glue service to crawl that data, and that's structured data, and it can be JSON, it can be CSV, a bunch of other formats, and you can actually go through and define tables of data that define the schema of that data, if you will. What data is in what fields are in the data, and in which order, and so on and so forth. And then you can query against that using standard ANSI SQL, right? That's one of the best things about it, is at the end of the day, if you already know SQL, you can kind of manage query against that data pretty easily. All right, I have a couple more questions. We're running up right at the end of our time. I'm going to try to get through a few more before we wrap up. So the next question here is from Adrian Drummond, and he says, can we have a high availability connection to AWS and automate the deployment and connections of future accounts and VPCs? So the answer is yes-ish, right? Pretty much everything in AWS can be provisioned through an API. And most of that is available using templating languages like CloudFormation and Terraform. If you use automation to look at some sort of database somewhere and then update those definitions, you could automate kind of deployment and connections for future accounts and VPCs. I will say, if you have kind of a hybrid approach, sometimes networking hardware can be a little bit old school and doesn't provide nearly as much in the way of an API. There's a lot of CLI going on, so that can be a challenge, but there are some great, more modern kind of networking platforms out there that you can use. This is a great question. I'll make this the last one. What I'll do is, once we end the webinar, I'll try to include some of these questions afterwards in perhaps a follow-up email. We'll see how much more I can get through before Josh tells me I have to be kicked out of this room. How often does AWS Well-Architecture update its standards? Like, for example, Athena just came out last year. How often should we go through the well-architected review process? So AWS updates the well-architected framework on a regular basis. So if you actually go look at the white papers themselves on their website, you'll notice a last update, and they'll have a record of how often a particular frame or pillar has been updated. And it really does vary on a pillar-to-pillar basis, depending on the services that they announce and as things evolve. But because it is the definitive collection of best practices that AWS recommends for its customers, they do a very good job of keeping it up to date. So the moment that a new service is released, you tend to see either a white paper addendum or a new version of the white paper, if there are additional kind of recommendations around that. And how often should you go through the well-architected review process? I would recommend going through it on an annual basis. And the cool thing is that program we discussed before, the well-architected review program, where you can get that $5,000 credit, that is based upon a per workload review. So even if you have one account with 30 workloads in it, each one of those workloads, you could get a separate well-architected review from our team and a separate $5,000 credit, right? So, we would go through it on a workload by workload basis. Let's see, I'm gonna probably have time for one more question, so I'm gonna look for the best one. Thank you, by the way, James, for the feedback. see. Okay, this is a pretty great question from Juan. He says, how do you apply fine-grained IAM roles for different microservices when they're deployed into the same EC2 and you want your microservices to assume the role in the EC2 instance instead of making them use a specific access key and secret key for each microservice? Very specific question, and I have a very specific response for you. Don't do that. Don't deploy your microservices onto a single EC2 instance. I know it can be useful from a cost perspective, but you should look into doing things like leveraging Lambda and moving some of those microservices out into a serverless environment, so you only pay for what you use. That'll save you money. It'll give you a lot more granularity around how you can control each of those microservices. And that's becoming easier and easier. I personally actually have been experimenting a lot lately with writing traditional kind of web services, microservices, and deploying them onto Lambda. You can actually now use a lot of these frameworks out here, such as the serverless framework for Node, and you can actually use that with other languages, like with Python. I use one called Zappa for Python. It allows you to actually deploy a Python web service as a Lambda function. And it hooks it all up for you through the API gateway, and it secures it with SSL and TLS. It's a really great approach to the problem, and it saves you money and less servers to manage as well. So I think that's all we have time for today. Thank you so much for attending today's webinar. We really appreciate it. Look out for next month. We'll have another one on the next pillar of the well-architected framework. And be on the lookout for a follow-up response for us for some feedback from you, which we'd really love your input, and with links to all of the content we've already produced. So appreciate it. Have a good one, and we'll see you next time.